Can you maybe share, Mariem, in terms of kind of the most exciting project that the team has ever worked on, or something that is life-changing to you that, can impact millions of people and we don't even know about it as a potential consumer or the general public? Please share a story or two of that. That would be awesome.
Yeah, of course. So I unfortunately can't mention a lot of customer names because of privacy, NDA, that kind of stuff. So for us, it's been, we've done different projects in different industries. And to me, that's the most exciting part of it. X-ray is a very kind of known, needed equipment in the electronics industry, but it's not as used in other industries where they could really benefit from seeing through their objects. And like I'd say probably one of the most exciting projects was anything that we have to do inline inspection, because it involves either conveyor belts or robotics. We've put like cobots on the outside of machines to load samples in and out, or robots inside of the machine itself so that they can, get the right angle of inspection and then sort the object into whatever categories the customer outlined. So those are the most exciting ones, and usually they come with custom software development. That's one of our, I think one of the things that makes us unique. We have a full engineering and software design team in-house. So just, like we really like to work with the customer. Anything that's like a custom application, that's not going to be a cookie cutter product. We not only do we like understand the piece of the puzzle that they're trying to fix, but we kind of like look beyond, like how else can we add value? And we end up building like some pretty complex machines with, laser thickness for measurements and scales to know the precise weights, and you can do measurements and things with X-rays. So anything that's like in line, I'd say, is the most exciting stuff. And then in terms of applications, we've done anything from high-end fashion to detect if a Chanel purse was a real purse or a fake. That one was pretty fun. We've done stuff in like the sports industry, like golf ball manufacturing, to know if things are aligned and centered. That makes for a better golf ball. Electronics, like I said, that's a big one. So we're looking for like voiding or like things, shorts and things like that. And yeah, medical devices, airbags. So really lots of different applications.
Wow, that's exciting. And I mean, if you think about a golf ball, you would really not think that has anything to do with electronics. And there you go. I learned something new. I remember someone said if you go to Top Golf, they track, that's probably, I don't know, but this seems a little bit more advanced than that. Right?
Just a little bit. So it's still related with that. You can get some measurements, and they're like measuring deflection of the ball, and whether it's the ball's fault or is it the person's bad golf, that's a debate that we can never figure out.
I love it. I love it. Sophia, what can you add? I mean, you've probably seen a lot of projects as well, the ones that you've really enjoyed.
Yeah, so as a process engineer for drill and route, what I've been focused on is basically just seeing how we can, like Mariem said, everything is getting smaller and more condensed, and everyone is, going towards having, smaller things that have a larger capability. So for projects, really, I've been involved in testing a lot of different things. So when we're drilling boards or when we're routing boards, each board circuit board is different. It's made up of, any number of layers of different circuitry, different materials, different thicknesses, different hole sizes, different shapes, everything like that. So just testing all of that and seeing how different materials react to different things has been a lot of fun. I've done processes trying to use a laser to kind of cut a shape into something, but not damage what was underneath it, which was pretty fun. Different sort of drilling or milling, different jobs. I'm trying to think of something, but yeah, I've done a lot of kind of testing and projects like that, where you're looking at different material interactions and different parameters and settings that achieve the best result.
And so what happens if something is totally wrong? What is the process? Is there a specific way that you need to go about fixing something, reporting it? Like, what does that level of inspection kind of need to comply with?
Yeah, so if something's totally wrong, there can be a lot of different things. So we have all circuit boards have specific standards that you have to be built to, so different rules, and then there's different classes of boards. So where I work is mainly for aerospace and defense. So we build for aerospace and defense for the most part. And so we're kind of the highest class of board. So you have to follow pretty strict rules and guidelines to be able to ship the boards and prove that they're good and that they're reliable. So for things like drill, if you're drilling a hole through a circuit board with the incorrect parameters, you can cause the material to have cracks, like almost like when you break glass, you have like a crack that goes through the layer, which is not good. Or you can take the material and smear it down the whole wall. You can cause really bad burrs on the exit side where the material kind of just pokes out on the exit side. So things like that are, if you don't do it the correct way, you can't plate the hole right. You can't, the process down the line doesn't matter because it will fail from what you did at drill or route. You can cause the edges of the board to fracture, which is not fun. Things like
Has it ever happened to you, like the whole fracture thing?
Yeah. It's being process engineering is really interesting because I can basically take my process and half of my job is trying to look at the process and improve upon it and see what you can do to make it overall, easier for operators to do their job. Basically make sure that you're add things in place that you don't scrap or you ruin and have to throw away boards. So that's kind of like making the process better, or with new technology coming in, totally coming up with and inventing a new process or a new procedure. So writing procedures, testing and writing processes, things like that. And then the other half is, since we're manufacturing, we're moving things through the shop every day. So I'll get in the morning and there's a list of things that are on hold for me because they have a question about something or they tried something and it doesn't look right. So the other half is basically problem solving, where I see a problem that we're having, and if it's if it is being drilled and they find an issue, I can fix it, like look at it there, fix it and move the panels. Or if it's something that comes up from inspection, then you kind of have to go back and solve the problem and kind of write the story on what happened, how did it happen, how are we going to fix it, how are we going to keep it from happening again. So it's kind of like two different sides. So that's why it's day to day completely different, because you can find different problems. I mean, it never ceases to amaze me the amount of different things that will pop up. That it keeps it interesting and exciting. And